So first thing we're talking about is bearing. So we've talked about angles of elevation and depression, and those always start at what kind of line? A horizontal, and then either goes up or down. Well, bearing is kind of the opposite. It goes from a north-south line.
I saw about these.
Did I give you 2 copies? You seem like you really want to take notes today.
I saw about these on some random computer's PDF when I was trying to figure out again how to do this.
So, bearing is formed from your north-south line to your given line. It is always an acute angle. There are 2 different ways that we could write bearing. So, you could say N or S. What do you think N or S stand for?
North and south.
North and south, your degree measurement, and then E or W for
East or west.
east or west. The other option is to just give a single degree measure with no north, south, east, west. And when you do that, it's measured from due north clockwise. So it's telling you from due north how many degrees clockwise you would turn. So, when we do these problems, we will always have to draw in our north-south line in order to measure our angle. So, your bearing is from one point to another. The point you are coming from is the point that has the north-south line at it. So when I'm looking at this, if I want to measure my bearing, if I'm going here, right, would I go north or south to get to B? We go north. From the north-south line, it is 40 degrees east. Okay, the second notation is from due north clockwise. How many degrees do we turn? Just 40 degrees. So those will be the 2 different ways we can measure the bearing of this one. All right, this one. If I'm starting at A to get to B, which direction do we go? Okay, then from my north-south line, we go 65 degrees west. The second notation is a single degree measure from due north going clockwise. So how many degrees would we have to spin?
295.
And we get that by doing 360 minus 65. All right. Next one. If I'm starting at A to get to B, which way are we going to go? South. From my north-south line, it is
70 degrees.
Or, if we are measuring from due north, how many degrees is that?
Is due north just from the north line?
Yes.
Okay.
We know from, like, the north to south, that would be 180. So you have to back up 70. All right, D. To get from A to B, so if I'm starting here, which direction do we go? South. From the east-west line, we go, or sorry, from the north-south line, we go 20 degrees west. Or, 180 plus another 20, 200 degrees. All right, last one. If I'm starting at A to get to B, I go? Okay, how many degrees? 0 degrees. Is it east or west? Neither. So technically, you can just put either one. So you could say north 0 degrees east, or you could say north 0 degrees west. Or the second notation is a single degree measure from due north. 0 degrees. So this one, if it lies on an axis, you just pick one of your directions.
Wait, for C, was it 180 minus 70? Is how we got the 110?
Yes. The key to these problems is drawing a good picture. In order to solve anything, we know we have to have a right triangle to use trig functions. So we have to draw a good picture, and we have to figure out where the right angle is in our triangle. We can't just trust our picture to show us. We need to find it out for ourselves. So let's take a look at a problem. Radar stations A and B are on an east-west line, 8.6 kilometers apart. So east-west line would be what kind of line? Horizontal line. A, B, that's a horizontal line, even though my picture doesn't look like it. And this measure is 8.6. Station A detects a plane at point C on a bearing of 53 degrees. As soon as I say bearing, bearing is measured from what? North-south line. So we are at point A. If I'm going to measure bearing, I need a north-south line at point A. So I just draw those in as dashed lines. Okay, if I just give you a single degree measure, that means from due north, we spin 53 degrees. So that would take me to point C. Station B simultaneously detects the same plane on a bearing of 323 degrees. So now I'm doing bearing from B. So we need north-south line from point B. Okay, we're looking at the same plane, but the angle I gave you is from due north all the way around to the south. I want the distance from B to C, so that's my x in this case, the thing I'm trying to find. Questions about the picture I've drawn?
Where's the right triangle? Oh, it's at the
We have to figure
At
out. It looks like it's at C, but do I know 100% certain? No, so we need to verify that that's a right angle. That means we have to find these angles in our triangle. So we know this is a north-south line, this is an east-west line. When a north-south and an east-west meet, what?
90 degrees, so you do 90 minus 52.
And that gives us 37 degrees for that angle. Okay, let's look at this one over here. If you go from here to here, that's 180, and another 90, so this would be 270. So we could do 323 minus 270 to get the angle in our triangle. Okay, so those add up to 90, which means this is in fact the right triangle.
Where did we get 270 from?
I was thinking from here to here would be 180 degrees.
Okay.
And another 90 to get to my east-west line. So that's 270. An XY axis. If you go, here's 90, 180, 270.
Okay.
Yeah, we only could do that because it told us we had an east-west line.
So we're looking.
So now, it's just a matter of setting up a trig function. So now it's like the homework you just turned in. We have to use one of our acute angles, so you can never set it up from the right angle, but we know both of them. So pick one. What do you want to use?
37.
37. Okay, from my 37, the side I'm looking for is opposite. 8.6 is hypotenuse. So the sine of 37 degrees equals opposite over hypotenuse. We talked about don't plug it in until the very end, so we multiply over the 8.6. 8.6 sine of 37 degrees is 5.1756. Let's practice significant digits one more time. We had 2 in the problem, so we would round this to 5.2 kilometers. So the key to these problems is drawing a good picture with Without a good picture, you're going to be very lost. Any questions for me? Let's try another. So, bearing from A to C. So we're starting from A. So A has to be my beginning point, and that's where you draw your north-south line, the place you're measuring your bearing from. To get to point C, we have to go north 64 degrees west. So this angle is from my north-south line over. That's 64 degrees. The bearing from A, so I'm back at A, to get to point B is south 82 degrees west. This is point B, and it's south 82 degrees west. Do I know, like, if my picture is drawn to scale? Like, do I know if point B should be here or if it should be over here? No, we're not really drawing anything to scale. We are just doing our best. But now it tells me to get from B to C. So that means if I'm measuring bearing at B, I have to be able to go north 26 degrees east. Am I going to have to fix my picture a little bit? Yeah. Point C has to be northeast of B. So whether you fix it by making this side a little bit longer, or I could just shorten this one a little bit, you may have to alter your picture some as you go. But that angle is not inside my triangle. That's from the north-south line. That was 26 degrees. So I don't have any angles given in my triangle right now. Is everyone with me? Let's see what else we're given. A plane flying 350 miles per hour takes 1.8 hours to go from A to B. I didn't tell you the length from A to B, but I gave you the speed and the time. Distance is rate times time. So if I take my speed times how long we were flying, 350 times 1.8 is
630.
Okay. So this side is 630 miles. Find the distance from B to C. So I'm looking for this side over here. Sometimes it's easy, like my picture wasn't very big. If you start losing your numbers in your picture, if you have too much, feel free to go out to the side and draw yourself another triangle if that helps you. You know, if you need a bigger picture, you can do that. But what do I need to know first of all?
Right angle.
Yeah, I need to know if there's a right angle so I can do this. So we need to start finding some of the angles in our triangle.
90 minus 26.
That only works if you know it's an east-west line. Don't these three together make 180 degrees? So if we do 180 minus 64 minus 82, that angle is 34 degrees. Okay. Now, the last angle, we need to figure out one more. And it's not as obvious. Can anyone figure out how we would get it?
Would the 64 be steep?
Not necessarily.
Would you subtract 26 from 90?
Close. So if we knew this was an east-west line, we could do 26 subtracted from 90, like we did in the last one. But I never told you it was east-west. However, these two lines are parallel, right? They're north-south lines. And that's a transversal. So at the very beginning, we talked about angle relationships. And that means this angle has to equal this one.
Oh.
So I would have to do 82 minus 26. And that gives me 56 degrees. That one was more challenging to figure out.
Where did we get the 34 from? What numbers did we?
We did 180 minus 64 because these two together made up the straight.
Where did we get the 64?
But you also subtract off the 82.
Where did the 32?
This is a straight. All right, if those two, we know that adds up to 90, so this means that angle is 90. All right, so that one was pretty challenging for figuring out our angles. Once we have that, though, we've done the hard part. So we just pick trig function involving the side we need. So which angle do you want to use? 34. Hit that first. So that would be the opposite and the hypotenuse. So the sine of 34 degrees equals the opposite side of x over the hypotenuse 630. So we have 630 times the sine of 34 degrees.
So you just do 350.
Yeah, so if we do significant digits, we have to match what was given. So that would be 350 minus. I think I'm going to bounce around a little bit on our examples. So are there any questions on this one? Significant digits, this is one thing we talked about in the last section. So if we look at the numbers given, this is 2 digits, this is 2, this is 2, 350. If there's not a decimal place, you don't count the 0, so it also has 2 significant digits. So it was kind of the idea that your answer can't be more accurate than the numbers given. If I rounded everything to 2 places, you would have to do the same for your answer. I want to go to this one. So if a 75-foot flagpole casts a shadow 43 feet long, where does the shadow go?
On the ground.
Okay. How many significant digits am I giving you?
3.
If there's a decimal, we count that 0, so this is 3. So this is 43. To the nearest 10 minutes, what is the angle of elevation of the sun from the tip of the shadow? So the tip of the shadow is here. Angle of elevation goes from a horizontal line up. So from here up, we are looking for this angle. What trig function would we do here?
Tangent of -1.
So we would assume that the flagpole makes a right angle with the ground. And then we could,
Carson, why'd you say -1?
so tangent is opposite over adjacent. So we need to find our angle, and anytime we're finding the angle, the only way to move the trig function away is to turn it into an inverse. So our angle is tangent inverse, or second tangent. So I get but I said nearest 10 minutes, so what do you have to do?
Multiply by 60.
take your decimal times 60. So we get 60 degrees and 10.3, so 10 minutes.
Good job.
So far, so good.
Question.
Mhm.
How do sync things work with that right there? Like when you're going degrees, minutes?
So the degree counts as 2 significant digits, and then the minutes would count as 2 unless you round to the nearest 10 minutes, and then it counts as 1. So like the 6 is a digit, the 0 is a digit, and this counts, but not the 0 and the 10.
Alright, thank you.
You're welcome. Other questions? Let's, I'm gonna keep jumping around. Let's go to this one. Okay, a boat travels on a course of bearing north 52 degrees 40 minutes east. So I've got to have my boat have a starting point. If I'm measuring bearing, we need a north-south line. My boat is going to go northeast. And the angle is from that north-south line. And it does this for a distance of 238 miles. How many miles east has the boat traveled?
So we cut it off.
Do
right?
distance, rate, and time, but you can plug.
What?
Never mind.
Why would you do it?
Never mind,
Just like
Carson.
take a right
Yeah,
triangle.
okay, we have to make a triangle out of this, right? And there's 2 ways to do that. We could either come over like this, or we could go up and over like that. Which one would probably be easier? Up and over, because then we have an angle in it already. If we just went east and west, north, south, that's a right angle. Which side am I looking for?
Yes.
East, the horizontal side. So what trig function would we use?
Sine.
And if we did significant digits, how many were given in the problem?
3.
3. So we would call it 189 miles. Okay. So bearing problems can be really complex, but not always. Sometimes I give you the information you need. Any questions on that? Let's do one last problem for today. Let's do this one. I went back a couple. How long should an escalator be? If it is to make an angle of 33 degrees with the floor and carry people a vertical distance of 21 feet between floors. What's an escalator?
Moving stairs.
Okay. Where's the floor go?
Under it.
Alright, so here's the floor. So the angle with the floor is 33 degrees. Where do I put the 21?
On
The on the line.
Set. Vertical.
Vertical distance. On the yeah, that one.
Yeah, that one.
Okay, what kind of angle would we have when a vertical line meets the floor?
90 degree, hopefully.
That's
Which side are we looking for?
Hypotenuse.
What trig function? So opposite side is 21 over hypotenuse, which is x. So you'll have to multiply over the x, and then what do we have to do?
Divide by sine.
So we get 38.5576. So significant digits, it would be
39.
39.
39 degrees feet.
All right. So technically, I've taught all the content you need from this. We will do more examples tomorrow. So it's 8 problems for today and tomorrow. You can get started tomorrow. I'll do some more examples with you, and you'll have some time to work on